NEC Section 220.12 covers general lighting loads and specifies how to calculate these loads for various occupancies. Subparagraph B specifically addresses track lighting. It states that for track lighting, a load of 150 volt amps per foot must be included in the feeder and service load calculations. However, this requirement applies to areas other than dwelling units. A multi-family dwelling unit for the purposes of the National Electrical Code is considered a dwelling unit. Therefore, the 150 volt amps per foot requirement of NEC 220.12b does not apply to track lighting installed in the hallways of multi-family dwelling units. The key phrase here is other than dwelling units. Hallways within multi-family dwelling units are considered part of the dwelling unit. The specific load calculation for general lighting in dwelling units is covered elsewhere in Article 220 of the NEC, typically using a volt amps per square foot method, and not the 150 volt amps per foot rule for track lighting. It is important to carefully review the definitions within Article 100 of the NEC to understand the precise meaning of terms such as dwelling unit, multifamily dwelling, and feeder. This ensures accurate application of the code requirements. When performing electrical load calculations, one must always consult the latest edition of the National Electrical Code and any applicable local amendments. These codes and amendments provide the minimum safety standards for electrical installations. Ignoring them can lead to unsafe conditions and code violations. Furthermore, understanding the intent behind code requirements is crucial for proper interpretation and application. In this case, the exception for dwelling units in NEC 220.12b recognizes that lighting loads in residential spaces are generally lower and more predictable than in commercial or industrial settings. This allows for a more streamlined load calculation method for dwelling units. Applying the 150 volt amps per foot rule to hallway track lighting in a multi-family dwelling would likely result in an unnecessarily high load calculation. This could lead to oversizing of feeders and service equipment, increasing costs without providing any additional safety. It's also essential to differentiate between dwelling units and common areas that are not considered part of a dwelling unit, such as lobbies, laundry rooms, or recreational facilities. The 150 volt amps per foot rule may apply to track lighting in these non-dwelling unit areas of a multi-family building. To reiterate, the exception in NEC 220.12b is specifically for dwelling units. Therefore, track lighting in hallways of multi-family dwellings is not subject to the 150 volt amps per foot requirement. Instead, the general lighting load calculation method for dwelling units should be used, typically based on volt amps per square foot. When working on electrical installations, always consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and standards. Correctly interpreting and applying the NEC is vital for ensuring safe and reliable electrical systems. The NEC is updated regularly to reflect changes in technology and best practices, so it's important to stay current with the latest edition. One should also be aware of any local amendments to the NEC that may be in effect in their jurisdiction. These amendments can modify or add to the requirements of the NEC, and compliance with them is mandatory. Understanding the specific requirements for different types of occupancies is essential for accurate load calculations. The NEC provides detailed guidance on load calculations for various types of buildings, including dwelling units, commercial buildings, industrial facilities, and healthcare facilities. The load calculation methods vary depending on the occupancy type, reflecting the different lighting, appliance, and equipment loads typically found in each type of building. For example, the load calculation for a dwelling unit is typically based on the square footage of the dwelling, while the load calculation for a commercial building may be based on the volt amps per square foot for different areas of the building, such as office spaces, retail spaces, and storage areas. In addition to the general lighting load, other loads that must be included in the feeder and service load calculations include appliance loads, motor loads, and heating and air conditioning loads. The NEC provides specific methods for calculating each of these loads. Appliance loads are typically calculated based on the nameplate rating of the appliance. Motor loads are calculated based on the horsepower rating of the motor and the voltage of the circuit. Heating and air conditioning loads are calculated based on the heating or cooling capacity of the equipment. It's also important to consider any demand factors that may be applicable to the load calculations. Demand factors are factors that reduce the calculated load to account for the fact that not all loads will be operating at their maximum capacity at the same time. The NEC provides demand factors for various types of loads such as lighting loads, appliance loads, and heating and air conditioning loads. Applying the appropriate demand factors can significantly reduce the calculated load, resulting in smaller feeder and service equipment sizes. Furthermore, voltage drop must be considered in the design of electrical circuits. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to operate inefficiently or malfunction. The NEC provides guidelines for limiting voltage drop in electrical circuits. The allowable voltage drop depends on the type of circuit and the load being served. For example, the allowable voltage drop for a lighting circuit is typically lower than the allowable voltage drop for a motor circuit. To minimize voltage drop, conductors should be sized appropriately, and the length of the circuit should be minimized. It is also essential to ensure that all connections are properly made and that there are no loose connections. Loose connections can create resistance and increase voltage drop. The correct application of the NEC is crucial for ensuring the safety and reliability of electrical systems. A thorough understanding of the code requirements and the principles of electrical design is necessary for performing accurate load calculations and designing safe electrical installations. Consulting with a qualified electrician or electrical engineer is always recommended when working on electrical installations, especially in complex or unfamiliar situations.